the Ancient Origins Sleep Script segment. Welcome to a journey through time and space. Let yourself settle in, find a comfortable position, and allow your mind to drift among the stars. Tonight, we're going to explore the Milky Way, our cosmic home, through facts that might surprise you, delight you, and gently carry you into peaceful sleep. Take a deep breath in and out, and let's begin at the very beginning. The Milky Way, our galaxy, is roughly 13.6 billion years old. Just let that number wash over you. 13.6 billion years. It's almost incomprehensible, isn't it? And yet, here we are, living within it, experiencing it in this very moment. To put this in perspective, the Milky Way is nearly as old as the universe itself. The universe, scientists believe, began about 13.8 billion years ago in that cosmic event we call the Big Bang. Just 200 million years later, in cosmic terms, barely a heartbeat, the first building blocks of our galaxy were beginning to form. Imagine floating back through time, past everything you know, past human civilization, past the dinosaurs, past the formation of Earth itself, back and back and back, to a time when the universe was still young and dark, when the first stars are just beginning to ignite like candles in an infinite darkness. That's when our Milky Way began its long, slow story. A story that continues tonight. As you listen to these words, as photons from distant stars travel across space to reach your eyes, connecting you to that ancient beginning, breathe in that cosmic history. Breathe out any tension you're holding, and let's continue our journey. A slow build. The Milky Way you see tonight, with its magnificent spiral arms and glowing central bulge, wasn't built in a day. In fact, the main disk and bulge took about 10 to 12 billion years to fully form. 10 to 12 billion years of slow, patient construction. Think about the most ancient thing you've ever encountered, perhaps an old tree, a mountain, an artifact in a museum. Now multiply that age by millions, by billions. The galaxy took its time. There was no rush, no deadline, just a slow, inevitable pull of gravity, gathering gas and dust, forming stars, building structure. It's rather comforting, isn't it? To know that some things cannot be hurried, that the most magnificent structures in the universe require patience, require time, require the gentle accumulation of small changes over eons. As you drift towards sleep tonight, remember that you, too, are part of this slow cosmic dance. Your atoms were forged in stars billions of years ago, scattered into space, gathered together again, becoming part of planets, oceans, life, and eventually you. There's no rush. Everything unfolds in its own time. Let that patience sink into your body. Feel yourself relaxing deeper and drift with me a little further back in time, the island universe. Here's something that might surprise you. Until the 1920s, less than 100 years ago, astronomers thought the Milky Way was the entire universe. Can you imagine? Every star they could see, every nebula, every cosmic wonder. They believed it was all contained within our single galaxy. The Milky Way, they thought, was everything that existed. In a way, it's a beautiful thought. Cozy even. The whole universe, comprehensible, contained, knowable. One cosmic island floating in an ocean of darkness. But then, in the 1920s, an astronomer named Edwin Hubble, yes, the Hubble Space Telescope is named after him, made a startling discovery. Those fuzzy patches of light that astronomers have been observing, they weren't just clouds of gas within our galaxy. They were other galaxies, entire galaxies, each one containing billions of stars of their own. In an instant, the universe became vastly, almost incomprehensibly larger. We went from believing we lived in an island universe to discovering we lived in an ocean of galaxies, billions upon billions of them, stretching out in all directions, as far as telescopes can see, and likely far, far beyond. And yet, here's the paradox. Knowing we're part of something so much larger doesn't make us smaller. It makes us more connected. Every galaxy, including ours, is part of the same cosmic web, the same story, the same universe. Let yourself feel that connection now. You are not separate from this vastness. You are part of it, woven into it, held by it. Ancient myths, long before telescopes, long before science. Humans looked up at that glowing band of light stretching across the night sky and wondered. They created stories to explain it. Beautiful stories that tell us as much about humanity as they do about the stars. The ancient Greeks, they had a particularly lovely explanation. They believed the milky band in the sky was milk, sprayed from the breast of the goddess Hera, queen of the gods. According to the myth, Zeus wanted his infant son Heracles, born of a mortal woman, to become immortal. So he placed the baby at Hera's breast while she slept. But Hera awoke suddenly and pulled away, and her divine milk sprayed across the heavens, creating the Milky Way. It's a myth about nourishment, about the sustaining power of the divine, about how even the accidental actions of gods can create cosmic beauty. And, in a way, they weren't entirely wrong. Our galaxy does nourish us. Every element in your body heavier than hydrogen was created inside stars, scattered into space, and reformed as planets and life. We are quite literally made of stardust, nourished by the cosmos. Feel your body now, heavy and relaxed, made of cosmic material, billions of years in making, resting here in this moment, safe and held. The Silver River. The Greeks weren't alone in their wonder. Across the world, in ancient China, people looked up at that same band of light and gave it a different name. They called it the Silver River, or, Tani, the River of Heaven. Imagine that, a silver river flowing across the night sky, a celestial waterway connecting earth to heaven. In Chinese mythology, this river even had a story. It separated two lovers, the weaver girl and the cowherd, who were only allowed to meet once a year, when a bridge of magpies formed across the Silver River. There's something deeply peaceful about thinking of the Milky Way as a river, isn't there? Rivers flow, constant yet ever-changing, ancient yet always new. They connect distant places, carry life, reflect light. Our galaxy does all of these things, flowing through space, its stars moving in great streaming currents, connecting solar systems, carrying the ingredient of life, reflecting and creating light. As you drift deeper into relaxation, imagine yourself floating on a gentle river, not of water, but of starlight, flowing slowly, peacefully, carrying you through the cosmos. No effort required, just drifting. The backbone, travel now. In your mind, to the Kalahari Desert in southern Africa. It's night, the air is cool, and overhead, in skies so dark and clear that the Milky Way seems almost bright enough to read by, the sand people look up at that luminous band. They call it the backbone of night. The backbone of night. Isn't that magnificent? It's not just a poetic name, it's a profound insight. The Milky Way does hold up the night. It gives structure to the darkness. It is the spine upon which the night sky arranges itself. Think about your own backbone, your spine right now, supporting you as you rest. Feel it from the base of your skull, down through your neck, between your shoulder blades, lower to your lower back, all the way down. It holds you, supports you, gives you structure without you having to think about it. The Milky Way does the same for our cosmic neighborhood. It's not just scattered stars. It's structure, it's home, it's the framework within which our solar system lives and moves. And you, resting here, are held by both. Your spine holds your body, the galaxy holds your world, and you can release and relax, knowing you're supported completely on every scale. Galileo's proof. Let's visit Italy now. The year 1610, a time when the world's understanding of the cosmos was about to change forever. A mathematician and astronomer named Galileo Galilei has just turned a new invention, a telescope, toward the night sky. What he saw, no human had ever seen before. When he pointed his telescope at that misty band of light called the Milky Way, expecting perhaps to see glowing gas or divine milk or a celestial river, he saw something altogether different and wonderful. Stars, individual stars. Thousands upon thousands of them, so numerous and so distant that to the naked eye they blurred together into a milky glow. But with magnification, they revealed themselves, separate, distinct, real. In that moment, Galileo proved that the river in the sky was actually made of countless individual stars. The mystery of the Milky Way, debated by philosophers for thousands of years, was solved by a simple observation. Look closely enough, and the cosmic haze resolves into countless points of light. There's meditation in that, isn't there? Sometimes what seems overwhelming or unclear or too large to comprehend reveals itself to be made of individual, comprehensible parts when we look closely. Your worries, your day, even your thoughts right now, they might feel like an undifferentiated blur. But each one, like each star in the Milky Way, is separate, individual, and ultimately countable. But you don't need to count them now. You don't need to solve anything. Just rest and let your thoughts blur together like stars in a galactic glow, becoming softer, gentler as you drift deeper, teenage years. Now, let's travel back again in time, back to when our galaxy was young. Between 13 and 8 billion years ago, the Milky Way was in what scientists call a teenage phase. If you've ever known a teenager or remember being one yourself, you know it's a time of intense activity, growth, change, energy. The galaxy was no different. During this period, our galaxy experienced intense star formation, billions upon billions of stars being born in great bursts of creation. Entire stellar nurseries lighting up across a galactic disk. It was, in a word, chaotic. Beautiful, but chaotic. Gas clouds collapsed, stars ignited. Some lived long lives. Others burned bright and exploded as supernovae, seeding space with heavy elements, which formed new clouds, which collapsed into new stars. A cycle of creation and destruction, of energy and transformation. Eventually, like all teenagers, the galaxy matured. Star formation slowed. Structure stabilized. The chaos gave way to the more stately, slower rhythm we see today. Our galaxy is now in its middle age, calmer, more settled, but still creating new stars, still evolving, just at a gentler pace. Perhaps you're in a similar phase yourself, past the intensity of youth, settling into a different rhythm. Or perhaps you're still in your own era of intense transformation. Either way, know that change is natural, growth takes time, and eventually, even the most chaotic periods give way to calmer seas. Let that calm wash over you now. Feel yourself settling, slowing, like a galaxy finding its mature form. The thick disk. And here's our final fact for this act. One that reveals just how complex our galaxy really is. During that teenage phase we just discussed, the Milky Way actually formed two disks. Not one, but two. A thin disk and a thick disk. The thin disk. That's what most people picture when they imagine a spiral galaxy. It's flat, only about 1,000 light years thick. It contains most of the galaxy's stars, gas, and those beautiful spiral arms you see in photographs. But beneath it, or rather surrounding it, is the thick disk. It's about 3,000 light years thick, more than twice as deep. It contains older stars, stars born during that chaotic teenage phase, moving in slightly more random orbits. Why two disks? Scientists believe the thick disk formed first, during those early violent times when the galaxy was still figuring itself out. Later, As things calmed down, as gas settled, the thin disk formed from newer material, creating the elegant spiral structure we see today. It's like geological layers in rock or rings in a tree. Each layer tells a story. The thick disk speaks of ancient violence and early formation. The thin disk speaks of later elegance and structure. Together, they make up the complete story of our galaxy. You, too, are made of layers. Your experiences, your memories, your growth. Some parts of you were formed in chaos, other parts in calmer times. And all of it, every layer, makes you who you are, complete. Oh, a story billions of years in the making. Let yourself feel those layers now. Let them settle, let them rest, one upon another, as you sink deeper into comfort, deeper into peace, deeper into sleep. And so we come to the end of Act 1, the ancient origins. We've traveled 13.6 billion years, from the galaxy's birth to its teenage years, from ancient myths to modern understanding. From Greeks to Chinese to the sand people of Galileo, all looking up at the same sky, the same river of light, the same backbone of night. Rest now. Let these cosmic timescales comfort you, knowing that you are part of something vast, ancient, and continuing. The Milky Way has been here for billions of years, and will be here for billions more, patient, steady, constant. And you are held by it, supported by it, made from it. Sleep well, under the silver river, beneath the backbone of night. Act 2, the anatomy of the giant, sleep script segment. Welcome back to our journey through the Milky Way. If you're still awake, that's perfectly fine. There's no pressure to sleep. Just let these words wash over you like gentle waves. And if sleep comes, let it come naturally. We've explored the ancient origins of our galaxy, and now we turn our attention to its structure, its anatomy, the architecture of this cosmic giant we call home. Take a slow breath in and out, and let's continue our exploration. Our type? Today, the Milky Way is what astronomers classify as a barred spiral galaxy. Let's break down what that means slowly, peacefully, like examining the petals of a flower. First, spiral. Imagine looking down on the galaxy from above. From a point far above the galactic North Pole, you'd see graceful arms curving outward from the center, like water spiraling down a drain in reverse, or like cream stirred into coffee, creating those beautiful, sweeping curves. These spiral arms aren't solid structures. They're more like traffic jams of stars. Imagine cars on a highway. Sometimes they bunch up, slow down, create a visible wave of density that moves along the road. The spiral arms are density waves, regions where stars, gas, and dust congregate, where new stars are born, creating those bright, luminous arms we see in photographs. And barred, that refers to the center. Instead of spiral arms flowing smoothly into a round central bulge, our galaxy has a bar, a rectangular structure of stars, stretching across the core like a cosmic axle around which everything else rotates. Not all spiral galaxies have bars, but ours does. We live in a barred spiral galaxy, and there's something oddly comforting about that specificity, like knowing your exact address in the cosmos. You are here in a barred spiral galaxy, in a specific spiral arm, on a specific planet, in this specific moment, located, placed, home, massive scale. Now let's talk about size. The Milky Way is approximately 100,000 to 120,000 light years across. 100,000 light years. Let that sink in. A light year, that's the distance light travels in 1 year. Moving at 186,000 miles per second for an entire year. That's roughly 6 trillion miles for a single light year. Now multiply that by 100,000. That's the width of our galaxy. It's so vast, so incomprehensibly large, that even moving at the speed of light, the fastest possible speed in the universe, It would take you 100,000 years to cross from one side to the other. If you started that journey when the first humans were painting on cave walls, you wouldn't even be halfway across yet. If you'd started when the dinosaurs walked the earth, you still wouldn't have finished. And yet, despite this enormousness, it's organized, structured. It's not chaos. Stars move in orbits, gas flows in patterns. Spiral arms maintain their shapes over millions of years. Even at these inconceivable scales, there is order, there is rhythm, there is a kind of cosmic choreography. Let yourself rest in that order, knowing that even the largest systems have structure, have patterns, have a way of holding themselves together. You, too, are held together by forces you don't need to understand. Just trust and relax. The population. How many stars live in our galaxy? Estimates suggest between 100 billion and 400 billion stars. 100 billion to 400 billion. That's not a small margin of error, is it? But when you're counting stars across 100,000 light years scattered through three-dimensional space, many hidden behind dust, it's remarkable we can estimate it all. Let's try to imagine 100 billion. If you counted one star per second, never sleeping, never stopping, it would take you more than 3,000 years to count them all. That's longer than recorded human history. And there might be 400 billion. For times that, 12,000 years of counting, one per second, never stopping. Each one a sun, many with planets. Some, perhaps, with life. Billions upon billions of worlds, most of which will never be visited, never be named, never be known. And yet they exist, shining in the darkness, doing what stars do, fusing hydrogen into helium, creating light and warmth, perhaps giving life to worlds we'll never see. There's a strange comfort in that vastness, isn't there? In knowing that you are one consciousness, among perhaps billions, in this galaxy alone. Not alone, but part of an immense family, most of whom you'll never meet, but who are there under the same galactic sky. Feel yourself as one point of awareness, among countless others, each one precious, each one unique, each one like a star shining in its own way. The central bulge. At the heart of our galaxy, there is a thick central bulge. It's about 10,000 light years in diameter, a dense sphere of ancient stars, packed more tightly than anywhere else in the galaxy. Picture it, a glowing core, warm yellow and orange light, the old heart of the galaxy, where stars orbit faster, where everything is more crowded, more intense. If you could visit the central bulge, the night sky would be spectacular. Thousands of stars bright enough to cast shadows. The sky never truly dark, always glowing with starlight, but it would also be dangerous. More stars mean more supernovae, more radiation, less stability. The galactic center is magnificent, but harsh. We're better off where we are, out in the suburbs of the galaxy, where stars are spread out, where there's room to breathe, where planets can evolve life in relative safety. Sometimes the center of things isn't the best place to be. Sometimes the edges, the quiet places, the overlooked corners, those are where the real magic happens, where life takes root, where consciousness emerges. You are here, not at the center of the galaxy, but in exactly the right place, for life to flourish, for you to exist, for this moment to happen. The bar. Now here's something fascinating. Recent data suggests that central bulge isn't spherical after all. It's shaped more like a bar than a sphere, a rectangular structure stretching across the galactic center. This was a surprise. For a long time, astronomers thought our galaxy's core was round, but with better observations, particularly in infrared light that can penetrate dust, they discovered the bar. It's about 27,000 light years long and perhaps 7,000 light years wide, a vast rectangular structure of stars, rotating as one. The bar serves a purpose. It funnels gas from the outer galaxy toward the center, feeding star formation. driving the galaxy's evolution. It's like a cosmic conveyor belt moving material inward, keeping the galaxy alive and active. We're constantly discovering new things about our own home. The Milky Way still holds surprises. Even now, after centuries of study, we're still learning its shape, its structure, its secrets. There's something hopeful in that, the idea that even the familiar can reveal new wonders. If we look closely enough, if we're patient enough, what familiar things in your life might reveal new depths if you looked at them with fresh eyes, but not now. Now is for resting, for letting thoughts drift like gas in a spiral arm, moving slowly, gently towards stillness. The disk, the main disk of the galaxy, the thin disk we mentioned in Act 1, is about 1,000 light years thick. 1,000 light years sounds like a lot, doesn't it? And it is vast beyond human comprehension. But compared to the galaxy's width of 100,000 light years, it's remarkably thin. If you scaled the Milky Way down to the size of a dinner plate, the disk would be about as thick as a few sheets of paper. Imagine that, a dinner plate made of 100 billion stars, most of them concentrated in a layer just a few sheets of paper thick. It's delicate in a way, fragile looking, and yet it's been stable for billions of years, held together by gravity, by the orbital motion of stars, by the invisible dark matter we'll talk about soon. We live in that thin disk. Our sun, our solar system, we're embedded in that sheet of stars, about halfway out from the center, orbiting slowly, taking about 225 million years to complete one orbit around a galactic core. The last time we were in this position in the galaxy, dinosaurs were just beginning to emerge on Earth. The next time we come around to this spot, who knows what will have evolved, what civilizations might exist, what wonders might have emerged. But that's far in the future. Right now, in this moment, we're here in the disk, part of the grand rotation, moving through space at 500,000 miles per hour, and yet feeling perfectly still, perfectly calm, perfectly at rest. Spiral arms. The Milky Way has two major spiral arms and several minor ones. The major arms are called the Scutum-Centaurus arm and the Perseus arm. We live in a minor arm, sometimes called the Orion spur or the Orion arm, a small branch between two of the major arms. Picture it, great sweeping curves of stars, arcing out from the center like the arms of a cosmic spiral, or the curve of a nautilus shell, or the spiral of a galaxy caught in photograph. Each arm is a river of stars, billions upon billions of them, flowing together in graceful curves. The spiral arms are where new stars are born. They're full of gas and dust, the raw materials of star formation. As the density wave passes through, it compresses the gas, triggers collapse, and new stars ignite, lighting up the arms in brilliant blue-white light. Our sun wasn't born in our current arm. It's drifted over billions of years, moving in and out of spiral arms, spending time in different regions of the galaxy. Stars don't stay in one arm forever. They move, they wander, they explore their galactic neighborhood. You too have moved through different phases, different places, different versions of yourself. And like a star drifting through spiral arms, you've gathered experiences, changed, evolved, and you'll continue to drift, to move, to change, but always part of the same galaxy, the same larger whole. Colors of age. Here's something beautiful. If you could see the Milky Way in true color from outside, you'd notice something remarkable. The outer disk appears blue, while the center appears yellow and orange. This is a color of age. Blue stars are young, hot, massive, and they burn fast and bright. They live only millions of years, not billions. They're the teenagers of the stellar world, burning with intense energy, living fast. Yellow and orange stars, like our sun, are older, cooler, more stable. They burn their fuel slowly, steadily, and can live for billions of years. They're the adults of the stellar world, mature, long-lived. The outer disk is blue, because that's where new stars are being born, right now, in clouds of gas and dust, igniting in brilliant blue-white splendor. The center is yellow, because those stars are old, formed billions of years ago, when the galaxy was young. You can see the history of the galaxy in its colors, the timeline of star formation written in light, the young outer regions, the ancient core, all visible if you know how to look. And you're somewhere in the middle of your own timeline, aren't you? Not newly formed, not ancient, but somewhere in between, still burning, still shining, still here. Let that be enough. Let yourself be exactly where you are, in your timeline, in your spiral arm, in this moment. A pizza analogy. Let's bring this down to earth for a moment, with an analogy that might surprise you. If the Milky Way were the size of a pizza, all the stars we can see with our naked eyes from Earth would fit inside one pepperoni. Think about that. On a clear night, away from city lights, you might see 2,000 stars, maybe 3,000 if your eyes are sharp and the sky is perfect. That seems like a lot, doesn't it? The whole sky filled with stars. But those 3,000 stars, out of 100 billion or more, would fit inside a single pepperoni on a pizza the size of the galaxy. Everything else, the other 99.997% of stars, are too distant, too dim, hidden behind dust, or simply beyond the resolving power of human eyes. We see only the tiniest fraction of our galaxy, the nearest neighbors, the brightest giants, the tip of the iceberg. And yet, even that tiny fraction is enough to fill us with wonder, enough to inspire myths and navigation and poetry, enough to make us feel small and connected and part of something vast. Imagine what we're missing. Imagine the wonders we cannot see, but don't strain to see them. Just rest, knowing they're there, billions of stars you'll never see, shining nonetheless, doing their cosmic work, unobserved but real, invisible matter. And now, we come to one of the deepest mysteries of our galaxy. About 90% of the galaxy's mass is invisible dark matter. Dark matter. It doesn't emit light. It doesn't absorb light. It doesn't interact with electromagnetic radiation at all. We can't see it. We can't touch it. We can't detect it directly. And yet, we know it's there. How? Because of gravity. When astronomers measure how fast stars orbit the galaxy, the math doesn't work out. There's not enough visible matter, not enough stars and gas and dust to account for the gravity that's holding everything together. The galaxy should fly apart, but it doesn't. Something invisible is there, providing additional mass, additional gravity, holding the galaxy together like an invisible scaffold. We call it dark matter, and it makes up 90% of the galaxy's mass. 90% of what our galaxy is something we cannot see. There's a metaphor here, isn't there? So much of what matters is invisible. Love is invisible. Thoughts are invisible. Memories are invisible. And yet they're real, they have weight, they affect everything. The Milky Way is held together by invisible forces. And so are you, held together by things you cannot see, but which are nonetheless real and powerful and essential. Rest in that mystery. Let yourself be held by forces you don't need to understand or see or name. The 5% rule. Here's an even more startling fact. Only about 5% of the galaxy's total mass is matter we can actually see. 5%. That's all. Everything you can see in the night sky, every star, every planet, every nebula, every galaxy in the universe, all of it put together, is only 5% of what actually exists. The rest is dark matter, which we just discussed, and dark energy, a mysterious force causing the universe's expansion to accelerate. Together, dark matter and dark energy make up 95% of the universe. We, the stars, the planets, the galaxies, the stuff we call normal matter, we're the minority, the exception, the rare 5%. And yet, it's that 5% that formed stars, that created life, that led to consciousness, that led to you, lying here, listening to these words, contemplating the nature of existence. 5% is enough, more than enough. You don't need to be everything. You don't need to be the majority. Sometimes, being part of the rare 5% is exactly what's needed to create something beautiful, something aware, something that can look up at the stars and wonder. The shield, dust. It sounds so simple, so harmless, but dust blocks our view of about 99% of the stars in the galaxy. The galaxy is full of dust, tiny particles, smaller than grains of sand, floating in the space between stars. They're made of elements forged in ancient supernovae, carbon, silicon, iron, the building blocks of planets. Beautiful stuff, essential for life. But from our perspective, trying to see across the galaxy is like trying to see through fog. The dust absorbs and scatters light, particularly blue and visible light. It dims stars, hides them, makes them vanish from view. When we look toward the galactic center, only 26,000 light years away, we can't see it in visible light. There's too much dust in the way, obscuring our view, creating a shield of darkness. But we've learned to see through the dust, using infrared and radio waves, which pass through dust more easily. With different eyes, we can see what visible light cannot show us. The galactic center revealed, the hidden stars made visible. Sometimes you need different eyes to see what's really there, different perspectives, different wavelengths. What seems opaque in one light becomes transparent in another. What seems hidden can be revealed if you know how to look, but not tonight. Tonight, let the dust be a blessing. Let it hide what doesn't need to be seen. Let it create darkness, soft and comfortable like a blanket, covering what can rest, what can sleep, the zone of avoidance. And finally, our last fact for this act, the area of the sky blocked by our own galaxy, the region where dust is thickest, is called the zone of avoidance. What a name, the zone of avoidance. It sounds ominous, forbidden, like somewhere you shouldn't go, but it's simply the band of sky along the galactic plane, where our own galaxy's dust and stars are so thick that we can't see beyond them to the distant universe. When astronomers map the universe, counting galaxies, measuring distances, there's a blank stripe across their maps, not because there's nothing there, but because we can't see through our own galaxy to what lies beyond. The zone of avoidance, a gap in our knowledge, created by our own cosmic neighborhood, obscuring our view. But again, we've learned to look in different wavelengths. Radio telescopes, X-ray telescopes, they can peer through the zone of avoidance, revealing the galaxies that hide behind our own. Nothing is truly forbidden, just harder to see. We all have zones of avoidance, don't we? Topics we don't examine, memories we don't visit, parts of ourselves we don't explore. And that's okay. Some things can wait. Some things don't need to be illuminated right now. Some things can remain in gentle darkness for a while. Let yourself rest in your own zone of avoidance, the place where you don't have to see everything, know everything, understand everything, the place where it's okay to simply be, without examination, without judgment, without effort. And so, we come to the end of Act 2, the anatomy of a giant. We've explored the structure of our galaxy, from its spiral arms to its central bar, from the stars we can see to the dark matter we cannot. We've learned that most of what exists is invisible and that sometimes our view is obscured, and that's perfectly fine. The Milky Way is vast, complex, mostly hidden, and yet it holds together. It functions. It creates. It endures. Just like you. Rest now. In your place in the galactic disk, held by invisible forces, surrounded by billions of stars you cannot see, but which are there nonetheless shining in the darkness. You are part of the anatomy of this giant, one small piece of an enormous structure, and that is enough. Sleep well. In a zone of avoidance, where not everything needs to be seen or known or understood. Act 3, the monster in the middle sleep script segment. Welcome to Act 3. We've journeyed through the origins of our galaxy, explored its vast anatomy, and now we travel to the heart, to the center, to the place where something mysterious, something powerful, something almost unimaginable waits in the darkness. Don't be afraid. We're perfectly safe here, billions of light years away, observing from a distance with wonder and calm curiosity. Breathe slowly in and out, and let's discover what lies at the very heart of the Milky Way. The heart, at the very heart of the galaxy, at the precise center of everything, lies a supermassive black hole. A black hole, an object so dense, so massive, that not even light can escape its gravity. A place where the normal rules of physics bend, warp, and ultimately break down. The point of no return, where space-time itself curves inward, creating a boundary called the event horizon, beyond which nothing, not matter, not energy, not information, can ever return. Every large galaxy, as far as we can tell, has one of these monsters at its center. A supermassive black hole millions or billions of times the mass of our sun, sitting at the gravitational center around which everything else orbits. Ours is no exception. The Milky Way, beautiful spiral, filled with hundreds of billions of stars, has at its very heart a supermassive black hole, the anchor, the center of mass, the point around which our entire galaxy rotates. And yet, from here, from our safe distance of 26,000 light years, we can't see it directly. It doesn't shine. It doesn't emit light. It's a hole in space, invisible, known only by its effects on everything around it. There's something profound about that. The center of our galaxy, the heart of everything, is invisible darkness, not emptiness, but concentrated mass, gravity so intense it becomes a kind of cosmic silence. And around this silence, everything dances. Let yourself feel that stillness, that central point of silence around which everything moves, but which itself is perfectly still, perfectly quiet, perfectly dark. The name, this black hole, the heart of our galaxy, has a name. Astronomers call it Sagittarius A star. Sagittarius, because it's located in the direction of the constellation Sagittarius, the Archer. When we look toward Sagittarius in the night sky, we're looking toward the center of our galaxy. We can't see the black hole itself, but we're looking in its direction toward the heart, the A* part. That's a naming convention from radio astronomy. A, because it was the brightest radio source found in Sagittarius. And the asterisk The star symbol, well, that's pronounced A star, a designation that makes it sound almost friendly, almost poetic. Sagittarius A star, our galaxy's dark heart, given a name that sounds like it could belong to a gentle star. We name things to make them knowable, to make them less frightening. A supermassive black hole sounds terrifying, but Sagittarius A asterisk, Sag A asterisk, that's almost affectionate. Scientists have been studying it for decades, watching stars orbit around it, measuring its mass, trying to photograph it, which they finally did in 2022, capturing the glow of matter swirling around the event horizon. Even the most mysterious things, the most powerful things, can be approached with familiarity, with patience, with time. What seems incomprehensible at first becomes, if not understood, at least known, named, recognized. What incomprehensible things in your life might become more familiar with time, but not now. Now is for rest, for letting mysteries remain mysterious. For a while, heavyweight, Sagittarius A asterisk, has amassed roughly 4 million times that of our sun. For million suns. Imagine our sun, a ball of plasma so massive that over 1 million Earths could fit inside it, generating enough energy to warm our planet from 93 million miles away. Now multiply that mass by 4 million. All of that mass compressed down into a region smaller than Mercury's orbit, compressed until the fabric of space-time itself cannot resist, until gravity becomes so strong that escape is impossible, until a black hole forms. For million solar masses, and yet in galactic terms, Sagittarius A asterisk is actually rather modest. Some supermassive black holes in other galaxies have billions of solar masses, tens of billions. Our galaxy's black hole is medium-sized, almost quaint, but still 4 million times the mass of our sun. It's the dominant gravitational force at the galactic center. Stars orbited at tremendous speeds, some completing an orbit in just 16 years, moving at a significant fraction the speed of light as they whip around the black hole. We can watch these stars year after year and trace their elliptical orbits, and from those orbits, calculate the mass of the invisible thing they're orbiting. That's how we know Sagittarius A asterisk is there and how massive it is. We see its effects, even if we can't see it directly. Gravity, invisible, patient, inevitable. It shapes everything, holds everything, even at the galactic center, where gravity is at its most extreme. There is order, there are orbits, there is structure. Feel that invisible force holding you. Right now, gravity, keeping you gently pressed against your bed or chair or wherever you rest. A force so fundamental, you barely notice it, but it's there, holding you, as it holds the galaxy, as it holds everything. Size, the black hole itself, the event horizon, is about 14 million miles across. 14 million miles. For perspective, that's about 15 times the diameter of the sun. It's roughly the distance from the sun to Venus, plus the distance from the sun to Mercury. That's the size of the boundary, beyond which nothing can escape. And yet, for something containing 4 million solar masses, that's remarkably compact. All that mass compressed into a sphere just 14 million miles wide. The density is incomprehensible, beyond anything we experience in normal matter. It's not made of atoms anymore. It's not made of anything we have words for. It's a singularity, a point of infinite density, where our physics breaks down, surrounded by an event horizon, a one-way membrane between our universe And whatever lies beyond, we can't see past the event horizon. We'll never know what happens inside. It's forever hidden from us by the very nature of space-time itself. Some boundaries cannot be crossed. Some mysteries cannot be solved. And perhaps that's okay. The universe keeps some secrets, and we can rest not knowing. We don't need to understand everything. We don't need to see beyond every horizon. We can be content with mystery, with boundaries, with things that remain unknown. Radio source, the galactic center, where Sagittarius A Asteris resides, is a very strong source of radio waves. Radio waves, not visible light, but longer wavelength radiation that our eyes can't see, but radio telescopes can detect. The first radio telescopes, built in the mid-20th century, swept across the sky, mapping the universe in this invisible light, and found something remarkable. The center of our galaxy was screaming in radio waves. Loud, bright, intense. Something that was generating tremendous amounts of radio emission. We now know that this radio emission comes from the region around Sagittarius A star. As matter falls toward the black hole, it heats up, accelerates, and emits radiation, including radio waves. The black hole itself is dark, but the swirling accretion disk of material around it glows, not in visible light. Most of that is blocked by dust, but in radio waves, which pass through dust as if it weren't there. This is how we first found the galactic center, not by seeing it, but by listening to it. In the language of radio waves, the heart of the galaxy announced itself. I am here, it whispered, in frequencies our eyes couldn't perceive, but our instruments could. Sometimes, you need to listen in different frequencies to perceive what's hidden, to hear what's not being said out loud. The universe speaks in many languages: radio, infrared, X-rays, gamma rays. And if we listen with the right instruments, with patience, with attention, we can hear even the quietest whispers from the most distant places. But now, let yourself stop listening, stop attending. Let the frequencies fade into quiet, into silence, into rest. Extreme light. Here's a startling thought. If we lived near the galactic center, the night sky would be as bright as day. Imagine that. No night, no darkness. The sky, perpetually illuminated by thousands upon thousands of brilliant stars, packed so closely together that they'd overlap in your vision, merging into a continuous glow. Shadows cast by starlight, enough light to read by, to see colors by, to navigate by, near the galactic center. Stars are packed much more densely than they are here. Out here in our neighborhood, the nearest star to our sun is over 4 light years away, near the center. Stars can be separated by just light weeks or even light days. Imagine stars as close to each other as the outer planets in our solar system. Imagine looking up and seeing not a few thousand stars, but hundreds of thousands, millions. It would be beautiful, overwhelming, and probably inhospitable to life as we know it. All that starlight would mean frequent supernovae, intense radiation, gravitational disruptions. Planets might not have stable orbits. Life might not have the quiet, stable environment it needs to emerge, to evolve, to become complex. Sometimes the quieter places are better, the darker places, the places that seem ordinary. Out here in the galactic suburbs, where the night sky is actually dark, where stars are distant enough to be discrete points of light, this is where life thrives. In the calm, in the quiet, in the spaces between. You are in the right place. Not the center, Not where everything is bright and intense, but here in the gentle darkness, where rest is possible, where peace is possible, where sleep is possible, the first black hole ever discovered, Cygnus X1, is also in our galaxy. Cygnus X1, it's located in the constellation Cygnus, the Swan, about 6,000 light years from Earth, much closer than the galactic center. It's a different type of black hole, a stellar mass black hole, formed from the collapse of a single massive star, rather than the supermassive black hole at the galaxy's heart. It was discovered in the 1960s, when X-ray detectors on rockets and satellites first scanned the sky. They found a powerful source of X-rays in Cygnus. Scientists studied it, observed a visible star orbiting something invisible, something massive, something that was pulling matter from a companion star, heating it to millions of degrees, creating those brilliant X-rays. The only explanation was a black hole, the first one ever confirmed, a breakthrough in astronomy, proof that these theoretical objects predicted by Einstein's equations actually existed in nature. Since then, we found thousands of black holes, stellar mass ones from collapsed stars, intermediate mass ones in globular clusters, supermassive ones at the centers of galaxies. Black holes, we now know, are common, normal, part of the cosmic ecosystem. What once seemed impossible, exotic, purely theoretical, became real, became accepted, became just another part of the universe. The impossible became possible. The unknown became known, and our understanding expanded. What seems impossible to you might one day become simply real, but there's no rush. Let things unfold in their own time as discoveries unfold across decades, across centuries, patient, inevitable Fermi bubbles. Now here's something extraordinary. Massive bubbles of radiation extend 25,000 light years above and below the galactic center. 25,000 light years. That's enormous. These bubbles, discovered by the Fermi Gamma Ray Space Telescope in 2010, are vast structures looming above and below the galactic disk like two gigantic balloons inflated by some ancient explosion. They're made of high-energy gamma rays. They glow in frequencies our eyes can't see, but which Fermi's detectors can map. When scientists first saw them, they were shocked. These structures are huge, and they were hiding, invisible to optical telescopes, waiting to be discovered in gamma rays. What created them? We're not entirely sure. The leading theory is that Sagittarius A*, our galactic center black hole, was much more active in the past. Perhaps a few million years ago, it consumed a large amount of matter, heated it, and blasted out tremendous jets of energy perpendicular to the galactic disk. Those jets expanded outward, creating these bubbles which persist even now, millions of years later, glowing in gamma rays. The galaxy has a history. It wasn't always as it is now. Our quiet, well-behaved galactic center might have been violent in the past, explosive, active, and the evidence is written in the sky in structures so large we didn't notice them until we looked in the right light. You, too, have a history, moments of intensity, moments of explosive growth, and the evidence is written in you in ways you might not always see, but which are there nonetheless. Your past has shaped your present, but it doesn't define your future. The Fermi bubbles persist, but they're fading. Slowly, eventually they'll dissipate. Even the most dramatic events eventually fade into calm, into quiet, into peace. Infrared vision, And finally, our last fact for this act. Scientists use infrared telescopes to peer through the dust to see the hidden core, visible light. The light our eyes see is blocked by dust. The galactic center, only 26,000 light years away, might as well be invisible, shrouded in cosmic fog. But infrared light, with its longer wavelengths, passes through dust much more easily. It's like the fog lifts and suddenly we can see. Infrared telescopes, like the Keck telescopes in Hawaii or the James Webb Space Telescope in orbit, can observe the galactic center in exquisite detail. They watch stars orbiting Sagittarius A star. They measure the motions. They map the structure. They pierce the veil that visible light cannot penetrate. This is how we know so much about the galactic center. Despite the dust, we changed our perspective. We looked in a different light. And what was hidden became visible. What was mysterious became mappable. What was unknown became understood. Sometimes the answers we seek are hidden behind obstacles, behind dust, behind darkness. But if we change our perspective, if we look in a different way, if we're patient and creative and persistent, we can see through, we can understand, we can discover. But not tonight. Tonight, let the dust remain. Let the darkness be a blanket. Let the mysteries stay mysterious. Let yourself rest in infrared warmth, in invisible light, in the gentle glow of things you don't need to see, to know are there. And so, we reach the end of Act 3, the monster in the middle. We've journeyed to the heart of our galaxy, explored the supermassive black hole, Sagittarius A asterisk, with 4 million solar masses, its radio whispers, its invisible presence. We've discovered Fermi bubbles, ancient evidence of past violence. We've learned how infrared vision pierces the cosmic dust. The center of the galaxy is not a gentle place. It's intense, powerful, extreme, and yet, from our distant perspective, it's beautiful, fascinating, a reminder that even the most powerful forces can be understood, can be named, can be observed with wonder rather than fear. You are safe here, 26,000 light years from the galactic center, orbiting peacefully in the calm suburbs of the galaxy, where night is dark, where stars are distant, where life can flourish in quiet contemplation. Rest now, held by the gravity of Sagittarius A asterisk, infinitely distant, and yet the anchor around which you orbit, the silent heart, the invisible center, the monster in the middle, that makes our galaxy whole. Sleep well in the darkness beyond the event horizon, where not everything needs to be seen or known or feared. Act 4, our place in the suburbs, sleep script segment. Welcome to Act 4. We've traveled far in our journey, from the ancient origins of the galaxy, through its vast anatomy, into the intense heart at its center. And now we come home to our place, our neighborhood, our small corner of this vast cosmic city. Let yourself settle deeper, feel the comfort home, and let's explore where we are in this magnificent spiral of stars. Location, our solar system, our sun, our Earth, our home, is about 26,000 light years from the galactic center. 26,000 light years. We're not at the center, where everything is bright and crowded and intense. We're not at the edge, where stars thin out and fade into the void. We're in between, in the suburbs, in the comfortable middle distance, where there's space to breathe, where the night sky is dark enough to see other stars, but not so empty as to feel isolated. If the Milky Way were a city, we'd live in a quiet residential neighborhood, not downtown, with its skyscrapers and traffic and constant activity. Not out in the countryside, distant and remote, but in the suburbs, safe, stable, peaceful, close enough to the center to feel connected, far enough away to have our own space. 26,000 light years. If you started traveling toward the center at the speed of light, you wouldn't arrive for 26,000 years. The journey we made in Act 3, when we visited Sagittarius A*, that was a journey in imagination. In reality, the galactic center is impossibly far, unreachably distant, and that's just fine. We are where we need to be, not at the center of things, not on the periphery, but here, in our place, 26,000 light years out, perfectly positioned for life to exist, for planets to be stable, for consciousness to emerge, for you to be here now, listening to these words. The Orion Spur. We live in a minor spiral arm called the Orion Spur. Remember from Act 2, the Milky Way has two major spiral arms, the Scutum-Centaurus arm and the Perseus arm. Grand sweeping curves containing hundreds of billions of stars. But we don't live in either of those. We live in a smaller structure, a minor arm, a branch connecting the major arms, the Orion Spur. It's named after the constellation Orion, because when we look toward Orion in the sky, we're looking along the length of our local spiral arm, our neighborhood, our section of the galactic disk. The Orion Spur is about 10,000 light years long and about 3,000 light years wide. It's a relatively small structure by galactic standards, a side street off the main boulevards of the major spiral arms. But it's ours. It's where we live, where our sun was born about 4.5 billion years ago, in a cloud of gas and dust somewhere in this arm, where the planets formed, where life emerged on Earth, where human civilization developed, looked up at the stars and wondered. You don't need to live on the main road to have a meaningful existence. You don't need to be at the center of everything to matter. Sometimes the side streets, the quiet neighborhoods, the minor arms, those are where the real life happens, where families grow, where gardens bloom, where peace is found. The Orion Spur is home, and home is enough. The orbit, just as Earth orbits the sun, our solar system orbits the galaxy. It's easy to forget that our sun is not stationary. It feels still, constant, fixed in the sky relative to Earth, but the sun is moving through space, orbiting like a planet around the center of the galaxy. Everything orbits something. Earth orbits the sun. The moon orbits Earth. The sun orbits the galactic center. The galaxy itself is moving, falling through space toward a great cluster of galaxies millions of light years away. Nothing is truly still. Everything is in motion, orbiting, falling, dancing through the cosmos. But you can't feel it, can you? You can't feel Earth spinning at 1,000 miles per hour at the equator. You can't feel Earth rushing around the sun at 67,000 miles per hour. You can't feel the sun's motion through the galaxy. It's too smooth, too constant, too large in scale. You feel still, at rest, and in a way you are. Motion and stillness are relative. You're moving through the universe at hundreds of thousands of miles per hour, and yet lying here, you are perfectly, completely still. Both things are true. You can be in motion and at rest at the same time. Let yourself feel that stillness now. Despite all the cosmic motion, despite Earth's spin, despite the sun's orbit, you are still. Calm, at peace, resting. The long year It takes about 230 million years to complete one full orbit around the galaxy. One galactic year, 230 million years. Let's sit with that number for a moment. A human year, 365 days, already feels long. A human lifetime, perhaps 80 years, feels vast, significant, full of moments and memories and changes. Now multiply that by millions, 230 million years. That's one orbit, one trip around the galaxy, one cosmic year. The last time our solar system was in this exact position, the galaxy, 230 million years ago, Earth was a very different place. The dinosaurs hadn't evolved yet. In fact, mammals hadn't evolved yet. The dominant life forms were reptiles, and the continents were joined together in a supercontinent called Pangaea. Earth was young in its history of complex life. The next time we come around to this position, 230 million years from now, Earth will be unrecognizable. The continents will have shifted again. New species will have evolved. Old species, including perhaps humanity, will be long gone, or transformed into something we can't imagine. The sun itself will be hotter, brighter, swelling towards eventual red giant phase. A galactic year is so long that everything we know, all of human history, all of recorded civilization, is a fleeting instant, less than the blink of an eye. And yet, here we are in this particular moment of this particular galactic year, alive, aware, experiencing this tiny sliver of cosmic time. You are here now, not 230 million years ago, not 230 million years in the future, but now, this galactic instant, this precious, brief, irreplaceable moment. Feel the gift of that, the improbability, the wonder. You exist now, in this cosmic moment, and that is extraordinary. High speed, the sun is traveling at roughly 514,000 miles per hour through the galaxy. 514,000 miles per hour. That's difficult to comprehend, isn't it? The fastest humans have ever traveled in spacecraft is about 25,000 miles per hour. The sun is moving more than 20 times faster than that and carrying us with it. Every second, we travel about 143 miles around the galaxy. Every minute, 8,580 miles. Every hour, 514,000 miles. We're rushing through space at speeds that would make any spacecraft look motionless by comparison. And yet you feel nothing. No wind, no acceleration, no sense of motion. Because everything around you, Earth, the moon, the planets, everything in our solar system is moving together. We're all in the same cosmic current, flowing together, and so, relative to each other, we're at rest. It's like being on a smoothly sailing ship. If you're below deck, with no windows, you can't tell you're moving. Everything seems still, stable, calm, only when you look out and see the water rushing past. Do you realize how fast you're going? We're on a cosmic ship, the solar system, sailing smoothly through the galaxy at 500,000 miles per hour, and it feels perfectly still, perfectly safe, perfectly calm. Let yourself rest in that cosmic ship, feeling the stillness, the safety, the gentle motion that feels like no motion at all. You are carried, held, moving through space without effort, without fear, without any need to steer. Life cycles. Our sun has orbited the galaxy about 20 to 25 times since it was born. 20 to 25 galactic years. The sun is 4.5 billion years old. Divide that by 230 million years per orbit, and you get about 20 orbits. 20 trips around the galaxy. 20 times the sun has traced its vast circular path through the Orion Spur, past countless other stars, through the spiral arms, completing the circuit again and again. Each orbit, a chapter in the sun's life. In the first few orbits, the sun was young, newly formed. The planets were still coalescing from the protoplanetary disk. Earth was molten, lifeless, being bombarded by asteroids and comets. By orbit 5 or 6, life had emerged on Earth. Simple single-celled organisms, quietly beginning the long story of biological evolution. By orbit 15 or 16, complex life had evolved. Plants and animals, the colonization of land, forests and oceans teeming with life. By orbit 23, the most recent orbit, dinosaurs rose and fell, mammals evolved, primates appeared, and in the last tiny fraction of this orbit, in just the last 250,000 years, modern humans emerged. We are living in the final moments of the sun's 20th or 25th lap around the galaxy, and the sun still has perhaps another 25 laps left before it exhausts its hydrogen, swells into a red giant, and eventually fades into a white dwarf. The sun is middle-aged, not young anymore, but not old, steady, reliable, burning bright, with billions of years still to go. There's something comforting about that, isn't there? The sun's story isn't over. There's still time, still laps to run, still light to give, still warmth to provide. The future is long and open. Whatever stage you're in your own life, know that, like the sun, your story isn't over. There are still orbits to complete, still light to shine, still warmth to give, mostly empty. Despite the billions of stars, the galaxy is mostly empty space. It's true. For all the stars, for all the planets, for all the gas and dust, the galaxy is mostly nothing. Vacuum, empty space, vast distances between points of light. If you could shrink yourself and fly through the galaxy, most of your journey would be through emptiness. Dark, silent, cold. Only occasionally would you pass near a star. Only rarely would you encounter a planet or a cloud of gas or another ship, if such things existed. The galaxy looks full in photographs, bright, dense, packed with stars. But that's an illusion created by photography. Long exposures, gathering light over time. In reality, space is mostly empty. The stars are separated by vast gulfs of nothing, and yet that emptiness is essential. Without it, stars would collide. Gravitational interactions would throw planets out of their orbits. There would be no stable systems, no long-lasting conditions for life. The emptiness is not absence, it's space, room, the necessary distance that allows things to exist without interfering with each other. You need emptiness too, don't you? Space between activities, silence between sounds, rest between efforts, darkness between lights. The empty spaces are not wasted. They're necessary. They're where you breathe, where you rest, where you find yourself again. Let yourself rest in the emptiness now. The vast, gentle, peaceful emptiness. Not lonely, not lacking, just spacious, open, free. Star distance. The average distance between stars is about 5 light years. 5 light years. That's the typical separation. Our nearest stellar neighbor, Proxima Centauri, is about 4.2 light years away. close to average. If you traveled at the speed of light, it would take 4 years and 3 months to reach it, and it's the nearest one. Imagine Earth, shrunk down to the size of a grain of sand. On that scale, the sun would be about the size of a small marble about 3 feet away from Earth, and the nearest star, Proxima Centauri, would be another marble about 400 miles away. That's the scale. Tiny points of light, separated by enormous gulfs. Stars are lonely in a way, isolated, each one burning in its own bubble of space, radiating light in all directions, with no guarantee that light will ever reach anything or anyone. Most starlight just travels forever into the void, never seen, never received, just traveling. But some of that light reaches planets, some reaches life, some reaches eyes that look up and wonder. And in those moments, the stars aren't lonely anymore. They're seen, appreciated, part of connection across the vast emptiness. You might feel lonely sometimes, isolated, like the spaces between you and others are too vast to cross. But remember, even across 5 light years, starlight connects. Even across enormous distances, communication is possible. Connection is possible. You are not as alone as you might feel. The neighborhood, the Orion Arm, where we live, is a major site of star formation. Star formation. New stars being born right now in our neighborhood, in clouds of gas and dust, scattered throughout the Orion Spur. Gravity is pulling material together, compressing it, hitting it, until ignition, a new star is born. A new light appears in the darkness. Some of these stellar nurseries are visible from Earth. The Orion Nebula, one of the most photographed objects in the night sky, is a stellar nursery in our arm, about 1,300 light years away. You can see it with binoculars, a fuzzy patch in Orion's sword, but through a telescope or in photographs, it reveals itself as a vast cloud of gas, glowing pink and purple, with newborn stars emerging from its depths. We live in a nursery, a place where creation is happening, where new stars are forming, where the galaxy is, in some small way, renewing itself, not in the old, quiet parts, but here in our neighborhood, where materials are available, where conditions are right, where birth is possible. Perhaps that's true of your life as well. Perhaps you're in a phase of creation, of new beginnings, of possibilities being born. Or perhaps you're resting between creations, gathering materials, waiting for the right conditions. Either way, know that you live in a fertile place, a place where new things can emerge, a place where, with time and the right conditions, stars are born, home, and finally, our last fact for this act, the Milky Way is the only place in the universe where we know life exists. Let that sink in. We've sent our telescopes out into the cosmos. We've observed billions of galaxies, trillions of stars, countless planets. We've searched for signs of life, for radio signals, for atmospheric biosignatures, for anything that might indicate we're not alone. And so far, we've found nothing, no confirmed life anywhere, except here, in the Milky Way, on Earth. Now, that doesn't mean life doesn't exist elsewhere. The universe is vast, inconceivably so. There are more stars in the universe than grains of sand on all of Earth's beaches. And many of those stars are planets. The odds seem overwhelming that life must exist somewhere else. But we haven't found it yet. We haven't confirmed it. As far as we actually know, as opposed to what we suspect or hope. Life exists only here, only in this galaxy, only on this planet. Only you, only us. The Milky Way is home, not just your home, not just Earth's home, but as far as we know, it's the home of all life, the only place in the entire observable universe where matter became complex enough to look at itself and wonder. You are, therefore, incredibly precious, incredibly rare. You are part of the only known instance of the universe becoming conscious of itself, the only known place where atoms arrange themselves into patterns capable of thought, of feeling, of love, of wonder. The Milky Way contains, as far as we know, all the life there is, and you are part of that life, part of that extraordinary, improbable miracle. And you are here now, in this moment, experiencing existence. That is enough, more than enough. It is everything. And so we come to the end of Act 4, our place in the suburbs. We've explored our location, 26,000 light years from the center in the Orion Spur. We've learned about our orbit, our galactic year, our high-speed journey through space that feels like stillness. We've contemplated the emptiness between stars, the distances that separate, and the neighborhood where stars are born. And we've come home to the recognition that this galaxy, the spiral of stars, is the only place we know where life exists, where you exist, where consciousness looks out at the universe and understands its place within it. You are home in the Milky Way, in the Orion Spur, on Earth, in this moment, exactly where you need to be, held by the galaxy, surrounded by stars, part of the only known instance of life in the entire cosmos. Rest now in that knowledge. Rest in your place, in your home, in the cosmic suburbs where life is possible, where consciousness emerges, where you are. Sleep well in the Orion Spur, in the gentle suburbs of the galaxy, where stars are being born, where life flourishes, where you belong. Act V, a history of violence, galactic cannibalism. Sleep script segment. Welcome to Act 5. We've journeyed through time, through structure, to the heart of the galaxy, and found our home in the suburbs. Now, we turn to a different kind of story, a story of violence, of collision, of consumption, the story of how our galaxy grew through a history that is dramatic and yet strangely beautiful. Settle in, breathe slowly, and let's explore the turbulent past that created the peaceful present in which we rest. Hungry galaxy, the Milky Way, our home, grew by consuming smaller galaxies throughout its history. Galactic cannibalism. It sounds violent, doesn't it? Predatory, aggressive, and in a way, it is. Large galaxies like ours grow by capturing and absorbing smaller galaxies that wander too close. Gravity, that patient, inevitable force, pulls them in, tears them apart, scatters their stars, and incorporates them into the larger whole. This is how galaxies grow, not gently, not through quiet accumulation of gas and dust, but through mergers, through collisions, through the violent incorporation of smaller systems into larger ones. It's the way of the cosmos. The strong grow stronger. The small are absorbed. And over billions of years, through countless mergers, galaxies like the Milky Way reach their current size. But here's the remarkable thing. When galaxies collide, when the Milky Way consumes a smaller neighbor, individual stars almost never collide. Remember, stars are separated by vast distances. When two galaxies merge, Their stars pass through each other like phantoms, like two clouds of gnats, interpenetrating, mixing, but rarely touching. So the violence is structural, gravitational. The shape of galaxies changes. Orbits are disrupted. Spiral arms might be destroyed or reformed. But the stars themselves survive. They're reassigned to a new galaxy, given new orbits, new neighbors, but they continue shining as if nothing happened. There's something almost reassuring about that. Even in cosmic violence, there's a kind of gentleness. Stars aren't destroyed. They're relocated, absorbed into something larger, made part of a new story, and they continue to burn, to shine, to exist. The Kraken, an ancient massive collision, has been dubbed the Kraken. The Kraken, named after the legendary sea monster. A collision so massive, so significant, that it left permanent scars in our galaxy structure. Scientists discovered evidence of the Kraken collision by studying the oldest stars in the Milky Way, looking at their orbits, their compositions, their ages. What they found was surprising. A large population of ancient stars moving in unusual orbits, not smooth circular paths, but elongated ellipses, tilted at odd angles, moving differently than the majority of stars in the disk. These stars were different. They didn't belong originally to the Milky Way. They were immigrants, captured from a galaxy that collided with ours billions of years ago, a galaxy that no longer exists as a separate entity, torn apart by tidal forces, its stars scattered throughout the Milky Way. We call that dead galaxy the Kraken. The Kraken was large, perhaps 1/4 the mass of the Milky Way at the time. When it collided with us, early in the galaxy's history, it didn't just merge quietly, it disrupted things, changed the structure of the young Milky Way, added mass, added stars, added complexity, and then it ceased to exist, not destroyed, but absorbed, dissolved, its identity erased. Its stars now are stars. The Kraken lives on not as a separate galaxy, but as part of us, integrated, inseparable. Sometimes losing yourself in something larger isn't an ending, it's a transformation. The Kraken is gone, but its stars remain, shining, part of a new story, part of the Milky Way. The sausage, a collision 10 billion years ago with a galaxy called the sausage, puffed up our disk. The sausage, another whimsical name for a cosmic catastrophe. This galaxy collided with the Milky Way about 10 billion years ago, early in our history, when the galaxy was still forming, still settling into its current structure. Why sausage? Because of the shape of the stellar orbits left behind. The stars captured from this galaxy move in elongated, sausage-shaped orbits, plunging to the galactic disk, arcing high above and below, then plunging back through, over and over, like a sausage. Astronomers have a sense of humor, but the sausage collision did something important. It puffed up our disk. Remember from Act 1, we talked about the thick disk, the layer of older stars surrounding the thin disk. The sausage collision is likely responsible for that. When it crashed through the early Milky Way, it stirred things up, added energy, pushed stars out of the plane, created that thick disk that persists to this day. 10 billion years later, we can still see the effects, the scars of that ancient violence, written in stellar orbits, in the structure of the disk, in the distribution of elements. The past leaves traces, always. Even after billions of years, the memory remains encoded in the motion of stars. Your past has shaped you too. Things that happened long ago have left traces in how you move through the world, in your patterns, in your structure. And that's okay. The past doesn't need to be erased. It's part of you, integrated, like the sausage integrated into the Milky Way. Current prey, we are currently absorbing the Canis Major Dwarf Galaxy. Right now, not billions of years ago, not in some distant future. Right now, at this very moment, the Milky Way is consuming another galaxy, the Canis Major Dwarf Galaxy, a small galaxy containing perhaps a billion stars that wandered too close and is now being torn apart by our gravity. The Canis Major Dwarf is located about 25,000 light years from our sun, below the galactic plane, moving through the disk. And as it does, the Milky Way's gravity is pulling it apart, stretching it, creating streams of stars that trail behind it like a cosmic ribbon, a trail of debris, the remnants of a dying galaxy. In a few 100 million years, perhaps sooner, the Canis Major Dwarf will be completely dissolved. Its stars will be scattered throughout the Milky Way, added to our population, indistinguishable from native stars. The galaxy will cease to exist as a separate entity. It will become us, and we don't even notice. Life on Earth goes on. Civilizations rise and fall. You live your life, all while in the background, in the cosmic machinery, the Milky Way quietly consumes another galaxy. It's so slow, so gradual, that it might as well be invisible. But it's happening right now. Change happens, even when we don't notice it. Slowly, gradually, over time scales too long to perceive. You are changing too. Every day, every moment. Cells replaced, thoughts evolving, experiences accumulated. You are not the same person you were yesterday, or last year, or 10 years ago. You are constantly being rebuilt, renewed, transformed. Let that transformation be gentle, like the absorption of a dwarf galaxy. Slow, inevitable, natural, immigrant stars. Many stars in our sky are likely immigrants from these dead galaxies. Look up at the night sky. Pick a star, any star. That star might not have been born in the Milky Way. It might be an immigrant, captured from one of the dozens of small galaxies that the Milky Way has consumed over its long history. Scientists estimate that a significant fraction of stars in the Milky Way, perhaps 10 or 20%, are immigrants. They didn't form here. They formed in other galaxies, smaller galaxies, galaxies that no longer exist. And when those galaxies were torn apart, their stars were adopted, given new orbits, new addresses, made citizens of the Milky Way. You can't tell just by looking. An immigrant star looks just like any other star. It shines the same way, burns hydrogen, lives its life. You need to study its orbit, its composition, its age to determine its origin. But once you know how to look, the evidence is there, hidden in plain sight. Maybe you're an immigrant too. Perhaps you've moved from one place to another, one country to another, one city to another, adopted a new home, been absorbed into a new community, and now you're indistinguishable from the natives, part of the whole, contributing your light, your energy, your presence. Or maybe you feel like an immigrant in other ways, like you don't quite belong, like you came from somewhere else. And that's okay. Immigrant stars are just as much a part of the Milky Way as stars born here. There's no hierarchy, no second-class citizens, just stars, all of them shining. The warp, the edges of the galaxy are warped and twisted due to the gravity of these neighbors. If you could look at the Milky Way edge on from a great distance, you'd notice something odd. The disk isn't perfectly flat. Near the edges, it warps, bends upward on one side, downward on the other, twisted, like a vinyl record left too close to heater. Why? Because of our satellite galaxies. The small galaxies orbiting us exert gravitational influence. They pull, they tug, and the outer edges of the Milky Way's disk, which are more loosely bound, respond. They warp, they twist like a piece of fabric. Pulled at the corners, the warp is subtle, only a few thousand light years of deviation out of a disk 100,000 light years wide. But it's there, measurable, real. The galaxy is not a perfect structure. It's messy, asymmetric, influenced by its neighbors, shaped by its environment. You're warped too, aren't you? Not perfectly symmetric, shaped by the people around you, the forces pulling on you. Family, friends, society, culture, they all exert influence. They all pull, and you respond. You bend, you adapt, you warp slightly to accommodate the gravitational pull of those around you. And that's not weakness. That's flexibility. That's being responsive. That's being alive. The wobble, the galactic disk wobbles like a spinning top. Picture a spinning top. As it spins, it doesn't stay perfectly upright. It wobbles, precesses the axis of rotation, traces out a cone, moving in a slow circle. That's precession. And the Milky Way does it too. The galactic disk, as it rotates, wobbles. The plane of the disk isn't fixed in space. It tilts, shifts, moves. Over millions of years, the orientation of the disk changes slightly, not dramatically, but measurably. Why? For the same reason the top wobbles. External forces, gravitational interactions with satellite galaxies, with nearby galaxies, with the uneven distribution of dark matter. All of these create torques, create wobbles, and the disk responds. Even the most massive structures are not perfectly stable. Even galaxies wobble. Nothing in the universe is truly rigid. Everything responds to forces. Everything moves, adapts, changes. And so, do you? You wobble. Your life isn't a straight line. Your path isn't fixed. You tilt, you shift, you respond to forces you can't always control. And that's okay. Wobbling isn't failing. It's being real, being dynamic, being responsive to the universe around you. Let yourself wobble. Let yourself be imperfect. Let yourself be influenced. Like the galaxy, you are strong enough to wobble and still hold together. Satellite count. We have nearly 60 small galaxies orbiting US right now. 60. That's how many satellite galaxies astronomers have discovered orbiting the Milky Way. Small galaxies, dwarf galaxies, some containing a few million stars, some containing a few 100,000, tiny by galactic standards, but real, distinct, orbiting us like moons around a planet. Most of them are faint, very faint, difficult to detect. We've only discovered many of them in the last few decades using advanced telescopes and surveys. And there are likely more, many more, perhaps hundreds of ultra-faint dwarf galaxies, too dim to see but out there, orbiting, held by our gravity. The Milky Way is not alone. It's the center of a small empire, a family of galaxies, all bound together by gravity, all orbiting our common center of mass. We're the largest, the dominant member, but we're surrounded by smaller companions, each one unique, each one with its own history, and we're consuming them, slowly, one by one, over billions of years. Some will survive, some will be torn apart. All of them are gradually being pulled closer. Eventually, they'll either escape or be absorbed. That's the fate of satellite galaxies. We all have satellites, don't we? Smaller relationships, orbiting our lives. Some close, some distant, some stable, some gradually drifting away, or closer. And that's the nature of relationships. They orbit, they change. Some last, some don't. And that's, okay, the Magellanic Clouds. Two small satellite galaxies, the Large and Small Magellanic Clouds, are our closest companions. The Magellanic Clouds. If you live in the southern hemisphere or travel near the equator, you can see them with your naked eyes. Two fuzzy patches of light in the night sky. Not quite stars, not quite clouds. Something in between. They're galaxies, small galaxies, orbiting the Milky Way. The Large Magellanic Cloud contained perhaps 15 billion stars. The Small Magellanic Cloud, perhaps 7 billion. Tiny, compared to our 100 billion or more, but substantial, real, separate entities, with their own stars, their own structure, their own identity. The Large Magellanic Cloud is about 160,000 light years away. The Small Magellanic Cloud, about 200,000 light years. Close by cosmic standards. Near neighbors, and they're approaching us, falling toward the Milky Way. In a few billion years, they'll collide with us, be torn apart, absorbed. Their stars will become our stars. But that's the distant future. For now, they orbit peacefully, beautiful companions, visible reminders that we're not alone in the cosmos, that the Milky Way is part of a larger structure, part of a family. Ancient cultures, particularly in the southern hemisphere, noticed the Magellanic Clouds, created myths about them. In Australia, Aboriginal peoples saw them as campfires. In South America, they were seen as parts of Celestial River. Always they were noticed, wondered about, named. We notice our companions too, don't we? The people close to us, orbiting our lives. Sometimes we take them for granted. Sometimes we wonder about them. But they're there, always there. Companions on this cosmic journey. The Magellanic Clouds remind us that even galaxies have companions. Even structures as vast as the Milky Way are not alone. There are others nearby, sharing the same space, the same gravitational dance, the same story. And you are not alone either. You have companions, visible or not, close or distant. You are part of a larger structure, part of a family, part of a system that holds together through invisible forces called gravity, called love, called connection. And so, we come to the end of Act 5, a history of violence. We've learned that our galaxy grew through consumption, through mergers with the Kraken, the sausage, the Canis Major Dwarf. We've discovered that many stars are immigrants, that the galaxy is warped and wobbles, and that we're surrounded by nearly 60 satellite galaxies, including our two closest companions, the Magellanic Clouds. The Milky Way's history is not peaceful. It's turbulent, violent, full of collisions and consumption. And yet, from all that violence came beauty, came structure, came us. The chaos of the past created the order of the present. The collisions built the galaxy we know. Perhaps your history is turbulent too, full of collisions, of absorptions, of changes, and perhaps that turbulence created who you are, made you stronger, more complex, more interesting. The violence of the past doesn't define you, but it shaped you, made you, you. Rest now, knowing that even galaxies have histories. Even the most beautiful structures came from chaos. And you, like the Milky Way, are still here, still whole, still spinning, still beautiful. Sleep well, surrounded by your satellites, your companions, your fellow travelers through space. You are not alone. You are part of a family, part of the structure that holds together through everything. Act 6, Life, Death, and Planets, Sleep Script Segment. Welcome to Act 6. We've traveled through time and space, through structure and violence, and now we turn our attention to life, to death, to the cycles of creation and destruction that fill our galaxy with worlds and wonders and possibilities beyond counting. Let yourself sink deeper, breathe slowly, and let's explore the living, dying, breathing galaxy in which we make our home. Billions of worlds. There are likely billions of planets in the Milky Way. Billions, not millions, billions. For most of human history, we knew of only 6 planets, the ones visible to the naked eye: Mercury, Venus, Mars, Jupiter, Saturn, and Earth. 6 worlds. That was the entire known population of planets in the universe. Then, telescopes revealed Uranus and Neptune, 8 planets. Still a small number, a countable number. But we wondered, do other stars have planets? Are we unique? Or is our solar system typical? For centuries, we couldn't answer. Planets around other stars, exoplanets, were too small, too dim, too hidden to detect. But in the 1990s, technology advanced, and we began finding them. First 1, then 10, then hundreds, then thousands. Today, we've confirmed the existence of over 5,000 exoplanets, and we've barely started searching. Based on the data we have, scientists estimate that nearly every star in the galaxy has at least 1 planet. Some have many. Do the math. 100 billion stars, at least 100 billion planets. Probably more. 200 billion, 300 billion, maybe more. Billions of worlds, rocky planets, gas giants, ice worlds, lava planets, ocean planets, planets we can't even imagine, each one unique, each one a world unto itself. Most of them will never be visited, never be named, never be known, and yet they exist, orbiting their stars, following the same laws of physics. Real, you are on one of those worlds. 1 planet among billions, a small rocky world orbiting a yellow dwarf star in the suburbs of the galaxy. 1 world among countless others. And yet, this is the world where you exist, where life emerged, where consciousness arose. This world is enough. Let yourself feel the gift of that, to be here on this world, this particular planet, among billions. Earth-like odds. There could be 40 billion Earth-sized planets, inhabitable zones, 40 billion. That's the estimate for planets, roughly Earth-sized, orbiting in the habitable zone of their stars. The habitable zone, sometimes called the Goldilocks zone, is the distance from a star where temperatures allow liquid water to exist on the surface. Not too hot, not too cold, just right. Liquid water is essential for life as we know it. So when we search for potentially habitable worlds, we look for planets in this zone. Rocky planets, about Earth size, orbiting at the right distance, where oceans could exist, where life might emerge. 40 billion of them in our galaxy alone. 40 billion chances. 40 billion laboratories where chemistry might become biology, where molecules might become cells, where cells might become organisms, where organisms might become conscious, aware, capable of looking up at their own sky and wondering. We don't know if life has emerged on any of them. We haven't found it yet. We're still searching, listening, looking for biosignatures in exoplanet atmospheres, for radio signals, for anything that might indicate we're not alone. But the odds seem encouraging. 40 billion chances. Even if life is rare, even if it requires very specific conditions, 40 billion opportunities suggest that somewhere out there life might exist. And perhaps somewhere on one of those 40 billion worlds, someone is lying down, resting, listening to their equivalent of this video, wondering if they're alone in the galaxy, wondering if on some distant world, someone else is looking up at the stars and thinking the same thoughts. Maybe, maybe not, but the possibility is beautiful. Most common star, 75% of the stars in the galaxy are red dwarfs. Red dwarfs, small stars, cool stars, dim stars. They're the most common type of star in the galaxy. By far, 3 out of every 4 stars is a red dwarf. And yet, we can't see any of them with our naked eyes. Not a single one. They're too dim. Red dwarfs are small, perhaps 1/10 to 1/2 the mass of our sun. They burn their hydrogen fuel very slowly, very efficiently. A red dwarf can live for trillions of years. Trillions. That's longer than the current age of the universe. No red dwarf that has ever formed has ever died. They're all still burning, still shining, and they will continue for unimaginable lengths of time. Our sun, a yellow dwarf, is actually unusual. Only about 7 or 8% of stars are like the sun. Most stars are smaller, dimmer, longer-lived. Red dwarfs are the norm, with exception, and many red dwarfs have planets. In fact, because they're so common, red dwarfs might host a majority of planets in the galaxy, including, perhaps, the majority of habitable planets. Because even though red dwarfs are dim, planets can orbit close to them and still be in the habitable zone. And red dwarf systems are stable for trillions of years, long enough for life to evolve, to become complex, to become who knows what. The most common things are often invisible, overlooked, unremarkable, and yet they might be the most important. Red dwarfs, humble, dim, ubiquitous, might be where most of the galaxy's life exists, if it exists at all. Perhaps you feel common, ordinary, unremarkable, but remember, the most common things are often the foundation, the backbone, the quiet majority that makes everything else possible. You don't need to be a bright blue giant to matter. You don't need to be exceptional to be valuable. You can be like a red dwarf, steady, long-lived, quietly shining. And that is enough. New stars. The galaxy produces roughly 1 to 3 new stars every year. Every year, 1 to 3 new stars ignite somewhere in the Milky Way. Right now, as you listen to these words, somewhere in a cloud of gas and dust, gravity is compressing material, heating it, building pressure. And soon, perhaps within this year, perhaps next, a new star will ignite. Fusion will begin. A new light will appear in the galaxy, 1 to 3 per year. That might not sound like much. In a galaxy of hundreds of billions of stars, what's 3 more? But over time, it adds up. Over 1 million years, 3 million new stars. Over 1 billion years, 3 billion new stars. The galaxy is constantly renewing itself, constantly creating. Even as old stars die, new ones are born. Star formation happens in molecular clouds, giant clouds of gas and dust, cold and dark, scattered throughout the galaxy. Within these clouds, gravity pulls material together, creating dense cores. And when a core becomes dense enough, hot enough, nuclear fusion ignites. A star is born. Often, many stars form together, in clusters, siblings, born from the same cloud. Our sun was likely born in such a cluster 4.5 billion years ago, along with hundreds or thousands of siblings. But over time, the cluster dispersed. The sibling stars drifted apart, scattered throughout the galaxy, lost each other forever. You had a beginning too, a birth, a moment when you came into existence. And like a star, you were part of something larger, a family, a community. Some connections remain, some drift apart. That's natural. That's the way of things. Stars and people drift through the galaxy, sometimes together, sometimes alone. Supernovae, a star explodes as a supernova in our galaxy about twice every century. Twice every century. That's the rate of supernovae in the Milky Way. On average, some centuries might see none, some might see several, but the average is about 2 per 100 years. A supernova is the death of a massive star. When a star much larger than our sun exhausts its nuclear fuel, it can no longer support itself against gravity. The core collapses. In less than a second, it rebounds and the outer layers explode, violently, spectacularly. For a brief time, a single star can shine as brightly as an entire galaxy. The explosion releases more energy in a few weeks than our sun will emit in an entire 10 billion year lifetime. It's almost incomprehensible, and it creates heavy elements: gold, platinum, uranium, elements that cannot be forged inside normal stars. Only in the extreme conditions of a supernova can these elements be created, and then they're scattered into space, enriching the gas clouds, from which new stars and planets form. Every atom of gold in your jewelry, every atom of iron in your blood, every heavy element in your body was created in a supernova billions of years ago. Some star long dead exploded, scattered its remains, and eventually those remains became part of you. You are made of stardust, quite literally. The calcium in your bones, the iron in your blood, the carbon in your cells, all of it forged in the hearts of dying stars. You are the universe experiencing itself. Death creates life. The end of one star provides materials for new stars. New planets, new life. Nothing is wasted. Everything is recycled. The universe wastes nothing. Hypervelocity stars. Some stars are moving so fast, they are escaping the galaxy entirely. Hypervelocity stars. Rogue stars. Moving at speeds of 1,000,000 miles per hour or more. So fast that the galaxy's gravity cannot hold them. They're leaving, escaping, heading out into intergalactic space, never to return. How does this happen? Usually through an encounter with the supermassive black hole at the galactic center. Imagine a binary star system, two stars orbiting each other. They wander too close to Sagittarius A star. The black hole's gravity tears them apart. One star falls in, consumed. The other is flung outward, accelerated to tremendous speeds, like a stone from a slingshot, fast enough to escape the galaxy. These hypervelocity stars are lonely, cut off from their companions, exiled from the galaxy, heading into the vast emptiness between galaxies. They'll travel for billions of years, through darkness, through nothingness, alone, and yet they still shine. Even in isolation, even in exile, they continue, burning their hydrogen, following the laws of physics, existing. Sometimes we feel like hypervelocity stars, don't we? Moving too fast, cut off, heading somewhere unknown, leaving behind everything familiar. It can feel frightening, lonely, but remember, even in the emptiness between galaxies, a star still shines. Even in isolation, you are still you, still burning, still real, still valuable. You carry your light with you. Wherever you go, whatever happens, that light is yours. It cannot be taken away. Magnetars. The galaxy contains magnetic stars that can strip credit cards from thousands of miles away. Magnetars, the most magnetic objects in the universe. They're a type of neutron star, the collapsed core of a massive star after a supernova, incredibly dense. A teaspoon of neutron star material would weigh as much as a mountain, and magnetars have magnetic fields 1 trillion times stronger than Earth's. How strong is that? If a magnetar were halfway between Earth and the Moon, about 120,000 miles away, its magnetic field would be strong enough to erase every credit card, hard drive, and magnetic strip on Earth. It would disrupt electrical currents in your body. It would be dangerous, lethal even, from 120,000 miles away. Fortunately, there are no magnetars that close. The nearest known magnetar is thousands of light years away, far enough to be safe. We can observe them from a distance. In X-rays, they flare, they pulse, they release tremendous bursts of energy, violent, chaotic, beautiful from afar. The galaxy is full of extreme objects, black holes, magnetars, hypervelocity stars, supernovae, extremes of temperature, density, energy, and yet here we are in a calm neighborhood, orbiting a stable star, on a planet with a gentle magnetic field, safe, protected, fortunate. Sometimes it's good to appreciate the lack of extremes, the calmness, the stability, the absence of magnetars and supernovae in our immediate vicinity. The galaxy can be violent, but here in our corner, it's peaceful, and that is a gift. Diamond stars, some dead stars, white dwarfs, are thought to have diamond cores. Diamond stars. It sounds like science fiction, but it's science fact. When a star like our sun exhausts its nuclear fuel, it sheds its outer layers. What remains is the core, a white dwarf about the size of Earth, but with the mass of the Sun, incredibly dense, hot at first, but slowly cooling over billions of years. White dwarfs are made mostly of carbon and oxygen, the byproducts of helium fusion. As the white dwarf cools, this carbon crystallizes. It forms a crystal lattice, and that lattice is essentially diamond, a sphere of diamond about the size of Earth, weighing as much as the Sun. There are likely billions of these diamond stars in the galaxy, old white dwarfs, long cooled, their fires extinguished, but transformed into something precious, beautiful, eternal. A star that once burned now shines in a different way, as a cosmic diamond. Death isn't always an ending. Sometimes it's a transformation. The star is no longer fusing hydrogen. It's no longer hot, but it's not gone. It's been transformed into something lasting, something crystalline, something that will persist for trillions of years, long after every other star in the current galaxy has died. When you change, when you transform, you don't disappear. You become something else, something new, and that new form might be just as beautiful, just as valuable as what came before, just different. Gas and dust. About 15% of the visible matter in the galaxy is gas and dust, not stars. 15%. That might not sound like much. Most of the galaxy's visible matter is locked up in stars, burning, shining, but 15% remains as gas and dust, the raw materials of creation, scattered throughout the galaxy, in clouds, in nebulae, in the spaces between stars. This gas and dust is where new stars form, where planets form. It's the reservoir, the potential, not yet transformed into stars and worlds, but waiting, ready when conditions are right. When a cloud becomes dense enough, it collapses and new stars ignite, new worlds form. The potential becomes actual. The gas is mostly hydrogen and helium, the lightest elements, left over from the Big Bang. But the dust, that's different. The dust is made of heavier elements: carbon, silicon, iron, oxygen, created inside stars, released when stars die, either gently in planetary nebulae or violently. In supernovae, the dust is recycled star material, and that dust becomes planets, becomes asteroids, becomes comets, and eventually, on at least one world we know of, it becomes life. The dust of dead stars becomes living, thinking, feeling beings, becomes you. You are made of recycled materials, stardust, elements that have been through multiple cycles, stars, supernovae, clouds, planets, life. You are the universe reusing itself, creatively, beautifully. Nothing is wasted. Everything is transformed. Galactic breathing. The Milky Way ejects and pulls in gas through galactic winds. The galaxy breathes, breathing. It's such a human metaphor, and yet it's accurate. The galaxy breathes, inhales, exhales, cycles gas in and out over millions of years. When massive stars explode, when black holes feed, when intense star formation heats gas, that gas expands, rises out of the disk, flows away from the galaxy like an exhalation, a galactic wind, carrying gas and energy and heavy elements out into the halo, into intergalactic space. But gravity, patient and persistent, eventually pulls much of that gas back down. It cools, condenses, falls back into the disk, like an inhalation, and the cycle continues. Out and in, exhale and inhale. The galaxy breathes. This breathing is essential. It regulates star formation. Too much gas, and stars form too quickly. The galaxy would burn out, run out of fuel, but the breathing moderates it, slows it down, ensures that star formation can continue for billions of years to come. You breathe too, in and out, a rhythm so natural you barely notice it, but it's essential. It regulates your body, brings in oxygen, removes carbon dioxide, calms your nervous system, centers you, connects you to this moment. Breathe with the galaxy now, slowly, deeply, in and out. Feel yourself part of the same rhythm, the same cycle. Breathing is universal, from galaxies to humans, from the largest scales to the smallest. Everything breathes. And so we come to the end of Act 6, Life, Death, and Planets. We've learned that billions of planets exist in the galaxy, including perhaps 40 billion Earth-like worlds. We discovered that red dwarfs dominate, that new stars are born and old ones die, that some stars escape the galaxy entirely, that magnetars bend magnetic fields, that white dwarfs transform into cosmic diamonds, and that the galaxy itself breathes. The galaxy is alive, not biologically, but in cycles, in processes, in the constant flow of matter and energy, birth and death, creation and destruction, breathing in and out. It's a system, dynamic, evolving, ongoing, and you are part of that system, made of its materials, following its rhythms, breathing its breath. You are not separate from the galaxy. You are an expression of it, a way the galaxy experiences itself. Rest now in that knowledge. You are part of the living galaxy, part of its cycles, part of its breath, and you, like the galaxy, will continue, transforming, renewing, breathing. Sleep well among billions of worlds, under skies filled with dying and birthing stars, in a galaxy that breathes just like you. Act 7, the dramatic future sleep script segment. Welcome to our final act. Act 7, we've journeyed to the past, explored the present, and now we turn our gaze forward to the future, the deep future, billions of years from now, when everything we know will have transformed in ways both dramatic and strangely beautiful. Let yourself rest deeply now. Breathe slowly, and let's explore what awaits our galaxy in the vast expanse of time ahead. The big collision, the Andromeda Galaxy, is rushing toward us at 110 kilometers per second. 110 kilometers per second. That's about 246,000 miles per hour. Andromeda, our nearest large galactic neighbor, about 2.5 million light years away, is approaching, moving through space, heading directly toward us. You can see Andromeda on a dark night with your naked eyes. It appears as a faint smudge of light in the constellation Andromeda, unassuming, peaceful, but that smudge is another galaxy, a spiral galaxy like ours, containing perhaps 1 trillion stars, and it's coming closer, every second, every day, every year, 110 kilometers closer, every single second. It sounds fast, and it is, but space is vast. So vast that even at this speed, Andromeda won't reach us for billions of years. We have time. So much time. More time than humans have existed. More time than complex life has existed on Earth. Time enough for evolution to run its course many times over. There's no need to worry. The collision, if it happens, is so far in the future that it might as well be infinite. You won't see it, nor your children, nor your children's children's children. For 1,000 generations, this is a story on time scale so long they cease to feel real. And yet it's happening. Right now, Andromeda drawing closer. Sometimes the most dramatic changes happen so slowly you never notice them in the moment. Only from a distance, across vast stretches of time, do they become visible. Change is like that, always happening, rarely visible, until suddenly, looking back, everything is different. 50 to 50 odds. There's a 50-50 chance of a direct collision in the next 10 billion years. 50-50. A coin flip. Will they hit or will they miss? Scientists aren't entirely sure. Measuring the sideways motion of Andromeda, its tangential velocity, is difficult, very difficult. We know it's approaching, but we don't know its exact trajectory. Is it headed straight for us, or will it pass to the side? Current best estimates suggest a 50% chance of a direct collision and a 50% chance of a near miss. Even a near miss would have dramatic effects. The gravitational interaction would disrupt both galaxies, alter their shapes, possibly trigger bursts of star formation. But a direct hit, that would be even more spectacular. 10 billion years. That's twice the current age of Earth, twice as long as Earth has existed. The sun will be near the end of its life by then, already swelling toward its red giant phase. Earth, if it still exists, will be a scorched, lifeless rock. Humanity, if it still exists, will have evolved beyond recognition, or left Earth entirely, or become extinct. 10 billion years is almost incomprehensibly long, but the galaxy will still be here, still spinning, still moving through space, and Andromeda will arrive. One way or another, the future is uncertain, but it's coming, inevitably, patiently. Your own future is uncertain too, isn't it? You don't know what will happen tomorrow, next year, 10 years from now, but it's coming, and that's okay. Uncertainty is not the same as danger. Not knowing is not the same as being unsafe. The future will unfold, as it always does. Milkomeda, if they hit, they will merge into one giant galaxy called Milkomeda. Milkomeda, a playful name for a cosmic event beyond imagination. The merger of the Milky Way and Andromeda, two spiral galaxies, each containing hundreds of billions of stars, colliding, interpenetrating, their spiral arms disrupted, their stars mixed, their gas clouds colliding, triggering spectacular bursts of star formation. The collision won't be quick. It will take billions of years. The galaxies will approach, pass through each other, their gravity pulling, stretching, creating long tidal tails of stars, streaming into space. Then they'll swing back, collide again, and again, each time losing energy, each time becoming more entangled, until finally, after multiple passages, they settle down, merge, become one. Milkomeda, a single giant elliptical galaxy, no longer spiral. The merger will destroy the spiral structure. The result will be round, smooth, filled with old yellow and red stars. Beautiful, but different. A new form, a transformation. The Milky Way and Andromeda will cease to exist as separate entities. Their identities merged, united, inseparable. It's like a relationship, two separate entities, coming together, colliding, disrupting each other, creating chaos, but eventually finding equilibrium, becoming one. The individual identities don't disappear. They transform, they merge, they become something new, something that contains both, but is neither. Milkomeda will be larger than either parent galaxy, more massive, more complex, a new story, built from two older stories. That's creation, that's transformation, that's the future. The LMC first, the Large Magellanic Cloud, will likely merge with us much sooner, in 2 billion years. 2 billion years. That's much sooner than the Andromeda collision. The Large Magellanic Cloud, our satellite galaxy, currently orbiting us peacefully, will fall in, merge with the Milky Way, be absorbed, just like the Kraken, just like the sausage, just like so many other galaxies in our violent past. The LMC contained perhaps 15 billion stars. When it merges, those stars will be added to ours. The collision will trigger star formation, will disrupt orbits, will possibly even wake up Sagittarius A*, our central black hole, causing it to feed, to shine, to become active again. 2 billion years. The sun will still be on the main sequence, still fusing hydrogen. Earth will be warmer than today. The sun will be brighter, hotter. Life on Earth will be struggling. The oceans might be evaporating, but Earth will still exist. And from Earth, if anyone is there to look, the night sky will be spectacular. The LMC approaching, growing larger, eventually filling the sky. But again, this is so far in the future that it's almost abstract. 2 billion years. It's beyond human timescales, beyond comprehension. And yet, for the galaxy, it's just another chapter, just another merger. The galaxy has done this before, many times. It will do it again. The galaxy is patient. It moves on timescales that dwarf human lifetimes, dwarf civilizations, dwarf species. And there's something comforting about that. The galaxy doesn't rush. It doesn't panic. It just continues, slowly, inevitably, patiently. Let yourself be patient too. Whatever you're waiting for, whatever you're working toward, there's no rush. Time is long, longer than you think. Things will unfold as they need to. Safe stars. Even if galaxies collide, individual stars are so far apart, they won't hit each other. This is important. When galaxies collide, it sounds catastrophic, violent, dangerous, and in some ways it is, but for individual stars, it's remarkably safe. Remember, stars are separated by vast distances, about 5 light years on average. When two galaxies interpenetrate, their stars pass by each other like two clouds of gnats, mixing, but not touching. The probability of two stars actually colliding during a galactic merger is effectively 0. It could happen, technically, but it's so unlikely that it probably won't. Not once. In a merger involving hundreds of billions of stars, probably not a single stellar collision will occur. So if you were somehow alive on a planet orbiting a star during the Milky Way Andromeda collision, what would you see? The night sky would change. Dramatically, new stars would appear, bright patches of star formation. The overall distribution of stars would shift. But your star, your sun, would be fine. Your planet would continue orbiting, undisturbed. The chaos is structural, not individual. The shape of things changes, but the pieces, the individual components, they survive. They're reassigned, given new context, new neighborhoods, but they endure. When your world changes, when everything around you shifts, remember this: you can survive, even when the structures you knew collapse or transform. Even when everything feels chaotic, the individual, you can endure, can adapt, can find your place in the new configuration. Ejection risk: there's a 12% chance our solar system could be kicked out during the merger. 12%, about 1 in 8. Those are the odds that during the Milky Way Andromeda merger, our solar system could be ejected, flung out of the merged galaxy, sent into intergalactic space, exiled like a hypervelocity star. How would this happen? Gravitational interactions during the chaotic dance of the merger, as stars and gas clouds swing past each other. Orbits are perturbed. Most stars will settle into new orbits in Milkomeda, but some will gain enough velocity to escape, to be kicked out entirely. And there's a 12% chance we'd be one of them. If that happened, what would it mean? From Earth, if Earth still existed, if anyone were there to see it, the night sky would gradually empty. The stars of the galaxy would recede. Over millions of years, they'd become more distant, fainter. Eventually, the Milky Way Andromeda merger, Milkomeda, would be visible as a distant smudge, and the rest of the sky would be dark, nearly empty. Just a few nearby stars, traveling with us, ejected, together. It sounds lonely, and it would be isolated from the galaxy, cut off from the galactic community, drifting through intergalactic space. But the sun would still shine, planets would still orbit, life, if it existed, would continue, just elsewhere, in exile. But there's an 88% chance we'd remain, stay with the galaxy, become part of Milkomeda, part of the new story. Most likely, we'll stay home. Or rather, we'll stay with what home becomes. Sun survival. The sun will likely survive the merger, though Earth will already be too hot for life. The sun will be fine. Stars are robust, hard to destroy. The sun will continue fusing hydrogen, continue shining through the entire merger, through all the chaos. It will endure, but Earth will not be fine, not because of the merger, but because of the sun's natural evolution. As stars age, they gradually get brighter, hotter. The sun, 10 billion years from now, when Milkomeda forms, will be about twice as bright as it is today, maybe more. That extra heat will have long since boiled Earth's oceans. The atmosphere will have been stripped away. Earth will be a lifeless, scorched rock, uninhabitable. This will happen long before the merger, perhaps in just 1 billion or 2 billion years. So the merger won't affect Earth, because Earth will already be dead, already gone, not destroyed, but transformed into something that can no longer support life. The planet will still be there, orbiting, but empty, silent, a tomb. That sounds sad, and in a way, it is, but it's also natural. Earth's habitability is temporary. It always was. Earth has been habitable for about 4 billion years, and it will remain habitable for perhaps another billion. That's a long time, long enough for life to emerge, to evolve, to become complex, to become conscious, to create civilizations, to reach for the stars, and then it will end, as all things do. But that ending is still 1 billion years away. 1 billion years. That's time enough for everything. You have time to, whatever you need to do, whatever you want to become. There's time, not infinite time, but enough time, more than enough. Black hole merge. The central black holes of both galaxies will eventually merge into one. Sagittarius A** and Andromeda's central black hole, currently called M31*, will meet. When the galaxies merge, these two supermassive black holes will spiral toward each other, slowly at first, over millions of years, getting closer, closer, until finally they merge. When two black holes merge, they release gravitational waves, ripples in space-time itself, traveling outward at the speed of light, carrying information about the collision. When Sagittarius A** and M31* merge, the gravitational waves will be spectacular, detectable across the universe. The merged black hole will be more massive than either parent, perhaps 10 million solar masses, perhaps more. It will settle into the center of Milky, the new gravitational anchor, around which all the stars, all the gas, all the structure will orbit. Two black holes becoming one, two singularities merging. It's almost poetic. The darkest objects in each galaxy, the invisible hearts, coming together, uniting, creating something larger, more powerful, more central. When two things merge, they don't lose their essence. They combine it. They create something new that contains both. That's true for black holes. And it's true for people, for ideas, for stories. Merging isn't losing. It's transforming. A quasar rebirth. This merger could turn our black hole into a brilliant quasar. A quasar, the brightest objects in the universe. Supermassive black holes, actively feeding, surrounded by brilliant accretion disks, shining across cosmic distances. We see them in the distant universe, in the early universe, but they're rare in the nearby universe. Most nearby galaxies, including ours, have quiet black holes, dormant, not feeding. But during a merger, gas falls toward the center, funneled inward by the gravitational chaos. And that gas feeds the black hole, heats up, forms an accretion disk, shines brilliantly. For a time, the center of Milky could become a quasar, outshining all the stars in the galaxy combined. If anyone were around to see it from a safe distance, it would be spectacular. The heart of the galaxy blazing, a beacon visible across millions of light years, announcing the birth of Milky, a quasar rebirth. The sleeping giant awakened briefly before settling back down, back into quiet dormancy. Sometimes dormant things awaken. Sometimes quiet things become loud. That's not wrong. That's part of the cycle. Activity and rest, brightness and darkness, both are natural. Both have their place. You don't need to be active all the time, bright all the time. Sometimes rest is appropriate, dormancy, quiet, and sometimes you blaze. Both are you. Both are valid. The end. As long as there's gas and dust, the Milky Way will continue to change and grow. And so we come to the end. Not the end of the galaxy, but the end of our journey, the end of our story. The Milky Way and its descendant Milky will continue as long as there is gas. as long as there is dust, as long as there are materials, to make stars, to make planets, to create. Eventually, trillions of years from now, the gas will run out, stars will stop forming, the last stars will burn out, the galaxy will grow dark, filled only with white dwarfs, neutron stars, and black holes. Cold, dark, quiet, that's the far future. The heat death, the end of everything. But that's so far away, it's almost meaningless. Trillions of years, thousands of times longer than the current age of the universe. By then, everything we know will be unrecognizable. The laws of physics might be different. Reality itself might have changed. But for now, for the next trillion years, galaxies will continue. Stars will form. Planets will orbit. And perhaps life will continue, evolving, adapting, spreading, from star to star, from galaxy to galaxy. Who knows? The Milky Way has been here for 13 billion years, and it will be here in some form for trillions more. That's continuity. That's endurance. That's the long view. You are part of that continuity, part of that long story. Your life is brief, but it's connected to everything that came before and everything that will come after. You are a link in a chain, stretching back to the Big Bang and forward into an unimaginable future. That's enough. That's more than enough to be part of the story, to exist, to be conscious, to look up at the stars and understand even a little where you are, what you are, when you are. And so, we've reached the end of Act 7, the dramatic future. We've learned that Andromeda is approaching, that there's a 50-50 chance of collision, that Milkomeda might form, that the LMC will merge sooner, that stars won't collide, that we might be ejected, that the sun will survive, that black holes will merge, that a quasar might be reborn, and that as long as there's gas and dust, the galaxy will continue. The future is uncertain, but it's also inevitable. Change is coming. Transformation, merger, growth. The Milky Way will not stay the same. Nothing stays the same. But that's not loss. That's evolution. That's the nature of existence. And you will change too. Transform. Merge with experiences, with people, with time. You will not stay the same. And that's okay. That's beautiful. That's life. Rest now, knowing that the future will take care of itself. The Milky Way doesn't worry about Andromeda. It just continues, spinning, existing, being, and you can do the same. The galaxy will be here tomorrow. And so will you, and that is enough. Sleep now, under the stars of Milky Way. Sleep. Know you are part of something vast, something ancient, something that will continue long after you've gone. Sleep, knowing you matter. You are seen. You are part of the story. Thank you for this journey through 13 billion years. Through spiral arms and black holes, through collisions and creations, through the past, the present, and the future. Thank you for being here, for existing, for being part of this remarkable galaxy we call home. Rest well, traveler. Rest well among the stars. The Milky Way holds you as it always has, as it always will. Good night.